Yes, welcome back to our online class. Yes, we are going to be treating ordinary differential equation. And first order ordinary differential equation, and we'll be taking some problems on how to use the variable separable method to solve some problems on the ordinary differential equation. Here are the problems. We have one of the question, the y dx is equals to x minus 5 over y squared. And the second question, the y dx equals to 1 plus y over 2 plus x. This is a question coined out from footer past question. So I have the third question here, the y dx equals square root of 1 minus y squared over 1 minus x squared. What is the concept? The concept is we want to relate the same variable with its derivative together. You are placing variables and derivative at the same position. Then you can integrate, and that's all. So let's get started. Solution. Now, question 1. We have the y, the x equals x minus 5 over what? Y squared. Now, you are going to ensure that your the y and your y are in the same position. Just equate, okay, y, everything related to y and the derivative, let's say at the left hand side, and anything related to x and the derivative at the right hand side. So that's what we're going to do. So here we can cross multiply, so that y squared multiply the y, I'm going to have y squared the y to be equal to x minus 5 multiply the x, and we have x minus 5 into what? Dx. Now I can integrate. So I will integrate the left hand side with respect to the y and integrate the right hand side with respect to the x. So let me try to expand this and open this up so that we have integral y squared y to be equal to integral x, the x, minus integral 5, the x. If I integrate this, I'm going to have y cubed over 3, integrating this with respect to the y. Likewise, if I integrate this, I'm going to have x squared over 2. Now, if I integrate 5 with respect to ds, I'm going to have 5x, then my plus c. Very good. Now, you are at liberty to cross multiply if you wish, and if I should cross multiply, I can have y cubed to be equal to 3 into x squared over 2 minus 5x plus c. Now I can like to make my y to have just one part instead of 3, then I'll take the cube roots of both sides. So I'm going to have y to be equal to the cube root of 3 into x squared over 2 minus 5x plus c all raised to the power 1 over 3. And that is what? The answer to that. So, very simple. Now let's take another question, question number 2. Let's take question number 2 here. We have the y over the x to be equal to 1 plus y over 2 plus x. So you're going to do the same thing. But in this case, if I cross multiply, we discover that I'm going to have the y, that let me write 2 plus x dx, that is this multiplying this, equal to 1 plus y the y, the 1 plus y the x. Yes. Now here you can discover that I will not be able to integrate this with respect to this. So it means I am going to do some division here. I'm going to divide this by 1 plus y and also divide this by 2 plus x. In that case, I have to multiply this by what? 1 plus y, and multiply this by what? 2 plus x. So that x will come to the side of the derivative of x and y will come to the side of the derivative of y. So this can cancel out this and this can cancel out this. So now I have the y over 1 plus y to be equal to the x over 2 plus x. Now I can bring in my integration. Now I can perform integration here. This is the integral symbol. Now if you observe from here, I can say let u here be equal to 1 plus y, so that my du dy will give me what? 1. Likewise here, if I say let v be equal to 2 plus x, so that my dv dx, if I differentiate this again, this 2 is a constant, is 0. If I differentiate x, I will have 1. Now I can say that my du here is equal to the y, and this side my dv here is equal to dx. So I'm going to replace my dy here with du and replace my dx here with dv. So I'm going to have, back to this, I will now substitute and have integral. My dy is du over 1 plus y is my u. Now is equal to my dx is now dv. Integral dv over 2 plus x is my v. Right? Now, so you know that integral du over u will give you what? Ln u. And that's a natural log of u. And this also gives me what? Ln v. And I can bring in my constant. So I have to substitute back my original values. My u is 1 plus 1. So I have ln into 1 plus y into ln into my v is what? 2 plus x, and that is plus c. So I can like to work for that. Let me bring this to the side so that I will have ln into 1 plus y minus ln into 2 plus x. Then I will have my what? Equal to c. From the laws of logarithm, logarithm of a minus logarithm of b is same thing as logarithm into a over b. So I can have 1 plus y over 2 plus x equal to c. So taking exponential of both sides, taking exponential of both sides. So this is just cancelling this out anyway. So I'm going to have exponential c is also a constant. This is a constant. Exponential of a constant is a constant. I can just say I have, let me say exponential c is constant c2. So it means that 1 plus y over 2 plus x equals to what? C2. And that is what? The answer. Now let us take third question here. The y dx equals to the square root of 1 minus y squared. That's question number 3. You have the y dx equals square root of 1 minus y squared over square root of what? Square root of 1 minus x squared. So we are going to do the same thing we did in the others. So from here, I'm definitely going to have the y over square root of 1 minus y squared, and here I'm going to have the x over what? Square root of 1 minus x squared. If you remember from your trigonometric substitution, this will give you what? Now we can bring in our integrator. If you are to integrate 1 over square root of 1 minus a squared, did you remember what you are going to have? It's going to be the what? Arc sine of a. That's the sine inverse of a. So that's what we're going to do here. So it means from here I'm going to have the sine inverse of what? Y to be equal to the sine inverse of x. I can bring in my plus c. And this is the answer. If you can go further, you can bring to this side, whether you like it or not. If you like it, you leave it this way. And that is the answer. Very interesting. So, thank you for watching. Remember, the deal is that you must be happy. I must be happy. We must be happy. So, do so well to subscribe, comment, like, and share.